Good afternoon. My name is David Robinson. I am a senior program manager on the SQL Azure team. And today we're going to be talking about migrating applications up to SQL Azure. And if you look at the agenda, first we'll give you guys a brief overview of what SQL Azure is. And then we'll go into some of the data tier considerations that you need to think about as you start to move your applications from on-premise SQL Server or other database platforms up to SQL Azure. And then we'll actually talk about some of the database migration strategies and just briefly talk about some of the future stuff. So just very quickly, who here is familiar with SQL Azure? A couple. Who's familiar with Windows Azure? Not too many. Who here is using SQL Server today? A bunch. And who here is really excited to hear about how easy it is to move your apps from SQL up to SQL Azure? Pretty much everybody. Awesome. Very, very good. So my name is Dave Robinson, as we went over already. I've been on the SQL Azure team for about 3.5 years. I was on the team before it was even SQL Azure, when it was just a bunch of people trying to figure out how we can build a massively scaled out version of SQL Server, and eventually became SQL Azure. And at PDC 2008 in Los Angeles, we announced the Windows Azure platform. And as you can see this slide up here, the Windows Azure platform is broken down into a bunch of different building block services. And the box all the way on the bottom left is something called Windows Azure. And Windows Azure provides you the hosting infrastructure for hosting your cloud-based applications. And it has something called compute, which is where your actual applications run. And then we also have storage and management capabilities built into the platform. And when we think about storage, Windows Azure has very rudimentary storage from a blob perspective and something called Windows Azure Table Store. And with the Windows Azure Table Store, it enables you to store very rudimentary key value pairs inside the platform. Moving over, what we'll be talking about today is something called SQL Azure. SQL Azure is the relational database of the Windows Azure platform. And for those of you that are familiar with SQL Server, you're gonna see as we go through some of the demos here today that it looks, acts, and feels a lot like SQL Server. All the investment that you've made in training your people and learning the SQL Server data platform, for the most part, just applies into the cloud. We move over one more. We have something called Windows Azure Platform App Fabric. And App Fabric contains two things. Number one being something called Service Bus. And Service Bus is a really, really cool product. And what Service Bus enables you to do is take some of the on-premise investments you have, some of the on-premise services, and securely expose that to the cloud, in addition to access control services for keeping everything on the platform secure. And then moving over one more to the right, we have something called Codename Dallas, which we announced, I guess it's about a year ago. And what Codename Dallas enables you to do is gain access on a pay-as-you-go model to these really, really rich data sets that typically would be cost prohibitive for people. It would, require a large capital outlay. And at the same time, when you have, data stores that you might find valuable, it also gives you the opportunity to take those data stores, move them up to the platform, and begin to monetize those as well. The key thing, though, that I want you guys to walk away from the slide thinking and have a really, really rich understanding is the same tools and the same technologies that you're used to dealing with today, whether it be Visual Studio, SQL Server Management Studio, the different Office products, they all continue to work. It's the same Microsoft technology foundation, just running up in the cloud. And in addition, as you've noticed, Microsoft's starting to embrace some of the open source technologies. You can actually go ahead and take your PHP application and run it within Windows Azure, and then use the PHP driver for SQL Server to connect up to SQL Azure and use that as your data store as well. So one of the promises of cloud computing is the ability to have this self-managed, elastic scale platform that will grow with you so that you don't have to make this big capital outlay before you go ahead and you approach a project. And that's exactly what SQL Azure is. And it's the first relational database as a service. And when we say as a service, there's a lot to that as a service part. As a service means that it'll be up and running no matter what happens. As a service means you don't have to worry about maintaining hardware. As a service means that if you need additional capacity, that capacity is sitting there waiting for you. You don't have to worry about over-provisioning hardware or worrying about what's going to happen if my database or my website sees a spike in traffic. With Windows Azure, you're able to very quickly just turn a dial and turn up the amount of capacity available to you. As far as developer agility, once again, it's the same tools that you've learned and you've come to love about Microsoft. The same developer ecosystem just works, for the most part, up on the Azure platform. So as we think about moving our applications up to Azure, it's important to think about the different types of application topologies that we see common in applications today. Excuse me. And we break that down into 3 different topologies. Something we call code near, code far, and this new thing that we're starting to see become very, very popular, which is a hybrid model. In code near, this is where the code that's accessing the database is running near to where the data is located. So in this model, we think of the application running up in Windows Azure and making either straight TDS, TDS being tabular data stream, which is the native network protocol of SQL Server, making native TDS calls to the database, or perhaps you've propped up a SOAP or a REST interface to running in the middle tier in Windows Azure. But the key to all this is that the database and the application are sitting next to one another. So you don't have to worry about things like the latency associated with the internet. It's very much similar to an application running within your enterprise today. Stepping over one, we have something that we call code far, where the application is running, for the most part, far away from where the database is. And so, we think about an application that potentially, later on, when I fire up SQL Server Management Studio and I access a database up in the cloud, I'll be actually, exercising that code far topology. Where things you need to think about is, what are the types of data access patterns that your application, sees and kind of access it makes to the database. Because if you have a very chatty application that makes lots of round trips back and forth to the database, that might not provide you the best experience on a cloud database. You might want to go ahead and take some of those transactions and batch them up. So that way, the round tripping back and forth isn't that detrimental to your application. I have a session later on today, I believe it's at 4:15, that actually goes into some of the different things you can think about from a performance standpoint when working with SQL Azure. And then the final model is something that we call the hybrid model. This is also commonly referred to as the offline model, the occasionally connected model, or everybody knows Outlook, where when you're connected to the internet, you're actually talking to the cloud-based database. But when you don't have an internet connection, or perhaps it's a very slow connection, you have a local data store. And then we employ the sync framework to keep those 2 data stores in synchronization. And you build the necessary logic into your application so that way it knows, am I talking to the local database, am I talking to the cloud database? And it helps you to provide a really, really rich experience to your users, whether or not they need to work while they're on an airplane or, one of the things I've learned, I've been in this area of the world for the past 3 weeks. And one of the things that, coming from the States, I have a fiber connection going to my house. So, we in the States, we take for granted how fast the internet speeds can be. But when we come out here, and we talk to customers and we hear from them saying, I have 500 clients that are on dial-up modems. We start to think about, we need to make sure as Microsoft that we're providing you the guidance and the necessary patterns so that when you do go ahead and move your applications up to the cloud, you're able to provide them with a rich, rich experience. So let's get into the meat of the talk, actually migrating applications. And this part of the talk, we're going to actually go into some of the different data tier considerations from when moving your database up to the cloud. Here we go. So supported APIs. Who here are developers versus DBAs? Developers? Any DBAs? There'll be some DBA stuff in there a little later on. But from a supported API support, things like ADO.NET, ODBC, Entity Framework, things like that, that's just supported out of the box. Things that are currently under the moniker of unsupported is OLADB. Now, why is OLADB unsupported? For the most part, OLEDB is unsupported because we haven't finished running all the extensive test suites that we have at Microsoft to certify that protocol as working against SQL Azure. Will it work? For the most part, we've seen it does. There are edge cases that we still need to work around, but for the most part it does. But we still need to keep the label of unsupported on top of it until we go ahead and we can stand behind supporting that protocol. From a connection string standpoint, anybody who's seen or heard any SQL Azure presentations, somebody always says, oh, just change the connection string. That's all you got to do. Just take the database, move it up, change the connection string, and it works. For the most part, it does actually. I was on stage giving the same presentation in Gold Coast last week, and I had actually a customer on stage with me who actually did that. They migrated their database, they had changed their connection string, and it did just work. Now, they did have an application that was a little chatty, so they're going through right now and optimizing it to make better use of the connections and hopping back and forth between the data tier and the database. But it does work. But one of the things you need to keep in mind is that since it is a database, it's sitting up on the internet, one of the things you need to specify in your connection string is this encrypt equals true. So what encrypt equals true says is that when you go ahead and connect to the database, make sure this is over an encrypted connection. So what happens if you don't say encrypt equals true? What happens is when ADO.NET or whatever the client you're using tries to connect to the database, it sends what's called a TDS pre-login packet, otherwise known as a login 7 packet. And inside that packet has all the different parameters for which you want to go ahead and connect to the database. When it sends that packet, if you don't have encrypt equals true, we respond with a reply saying, send me an encrypted connection. The next packet you send me, or I'm going to disconnect from you. And if they go ahead and try to reconnect without the encryption set on, and this all happens behind the scenes for you within ADO.NET and the other stacks. But for some reason, if it tries to connect unencrypted, we'll actually kill the connection. We will not allow you to connect unless that's over an SSL channel. So you might ask, if it's automatically handled for me, why specify the encrypt equals true? And there's actually, if you don't specify the encrypt equals true, there's a slight chance you could be open for what's called a man-in-the-middle attack, which basically means that somebody will be listening on that connection between you and SQL Azure, and it'll start spoofing those packets. So that's just something to keep in mind as far as connecting. As far as adding the @server name to the user ID, what we've seen is some of the older versions of ODBC and some of the older versions of ADO.NET, they haven't followed the TDS specification to the letter, and they don't send across the actual server name you want to connect to. And when SQL Azure gets this connection, since we do have a massively scaled out architecture, each one of your databases are living across many different machines. So we need to have that server name to know where to route your connection to appropriately. So for the newer implementations, .NET 3.5 and Snap, which is known as the SQL Native Access Client version 10, it knows about it. But if you're using some of the older client libraries, adding the @server name is probably a best practice that you want to go ahead and think about. Also, from a troubleshooting perspective, a lot of times we'll get calls to our service desk, and the first thing they'll tell people is, did you put the @server name? And they'll say no, and then when they do, sometimes it just magically starts working. So just something to keep in mind from a best practice perspective. As far as protocol support, TCP/IP over port 1433 is supported. Everything else is not. There's some obvious reasons why things like named pipes and shared memory is not supported. And one of the things I really like to call out on this slide is, working for Microsoft, one of the things we've always told people up until very recently was, do not expose your SQL Server on the internet. Do not open up port 1433. It's a bad practice from a security standpoint. And what did we go ahead and did? We went ahead and we opened up port 1433 and told people, oh, trust Microsoft, connect to us. The difference is that inside SQL Azure, we've built in a lot of security mechanisms behind the scenes to make sure that your database is secure and protected. Secure things like we have a firewall built into the system. So that way you have to actually go ahead inside the portal, which we might look at in a few minutes. You actually have to go into the SQL Azure portal and enable the actual IP address ranges that you want to allow to go ahead and connect to your database. In addition, we have things like denial of service mitigations built into the service, so that if it sees somebody trying to brute force someone's password, it'll go ahead and kill that connection. In addition, we get a lot of data from different security firms around the world as far as what are the most commonly brute forced usernames. So things like SA and administrator and root, you're not allowed to go ahead and actually go ahead and create a user account while using those accounts, because we do have data around, if I'm a script kiddie and I want to go ahead and brute force somebody's password, I know what they're going to go ahead and use. At the same time, we support SQL authentication, and we do not support Windows authentication. We are considering alternate, authentication and authorization models for SQL Azure, but today the only thing we support is SQL Auth. But it's the same exact implementation as with on-premise SQL Server. So what about connectivity? So I love SQL Server. I'm on a SQL Server team. One of the great things about SQL Server is that it will let you do whatever you want to do. It will just take it and it will just run with it. Things like if you write a bad query, SQL Server will just take it. If you have a flaky network, SQL Server will just take it. One of the things you need to keep in mind with SQL Azure is that it is an internet database. Microsoft, we cannot control the pipes that run from your client application all the way up to the database. So we think about having the code, this code far topology, and things you really need to worry about is adding connection retry logic inside your database, because once again, it's an internet connection. Internet connections, for the most part, they can be flaky. They do go down. But we've often found that if you go out to the SQL Azure team blog, which there's a reference to it at the end of the deck, there is, it's a common pattern that we're starting to see people use, where they just add very simple retry logic to their connection factory, and it really, really helps out with providing a resilient experience. Another reason that we like to do this is if you think about the fact that we have, a highly fault-tolerant, highly redundant database system. We maintain multiple copies of your database, and those replicas are maintained across multiple racks of machines that are fully redundant with multiple sets of networking equipment and power supplies and backups. When we go ahead and release a new service update, which we just did last week, we actually do this in a rolling fashion where we upgrade each one of your replicas separately. And as we're updating the replicas, we actually have to terminate the connection that you currently have to one replica and move it to another. And in that process, you could experience a disconnect from the database. So having this connection retry logic built into the system is a really, really good thing, and one of the key takeaways I want you guys to walk out of here with as you leave today. The other thing is throttling and load balancing. We'll go into details on this in the session later on this afternoon, but since it is a multi-tenant system and your databases are living on machines with other people's databases, if we see one machine start to get hot and start to come under a lot of load, we'll actually kick in automatically this load balancing, where it'll actually start to take those workloads and move them onto less busy machines and spread that load out across all the different machines in the cluster. So yet again, if we go ahead and move your database from point A to point B, it'll only be sub-milliseconds where that database is not online. But at the same time, we will cut the connection, so when you go ahead and do the retry, it'll be able to connect to the new replica. And I know I'm making this sound really harsh, and to be honest, we have another layer inside the system, something called a gateway, which actually knows where your databases are and does the appropriate routing. It does have retry logic built into it, so a lot of this hell and brimstone type talk I'm giving you right now, it's kind of extreme. For the most part, it's not as bad as I'm making it out to seem to be, but I just want you guys to know the types of things that can go on behind the scenes, and so that way you can actually go ahead and code around it. As far as collation is concerned, this is not too controversial in this part of the world, but when I go to places like Japan and Germany and whatnot, it's a very controversial topic. But for the most part, as long as you like SQL Lat in general, CP1, C1AS, then you're good to go. That is the only collation we support. We are looking, and you'll see in the future slide, we are looking to add additional collations. But just keep in mind that that's at the actual server and database level. If you want to go ahead and specify different column level collations, you're free to go ahead and do that. But that's something you need to keep in mind. And as far as feature parity, when people say, oh, SQL Azure is not compatible with SQL Azure, SQL Server is not compatible with SQL Azure and vice versa, you know what? It's true. There are aspects of SQL Azure that are not fully compatible with SQL Server. But for the most part, those incompatibilities, they're at the server level, not at the database level. So when you think about things like physical server administration, when you create a database, where does that data file go? Where does the log file go? What is the growth and the fill factor and things like that? Those things, we're incompatible with SQL Server because they don't apply when you're dealing with a cloud database. We talked earlier about how we have the as a service part of the database. The as a service takes care of a lot of these things for you. So for the most part, if it's at the server level, it's not supported because it's handled automatically inside the system for you. When you come down and you go into the actual database, we're at the 95, 98% compatible with actual on-premise SQL Server. The places we start to drift are the features that we haven't fully implemented, things like full text search. And why don't we support full text search? Well, the problem with full text search is that the catalog is shared across all the databases on the server. And so that way, if we enabled full text search today, there's a chance for data leakage from one customer's database to another. So we're in the process of doing all the work necessary to make sure that some of these more advanced features are sufficiently siloed in this multi-tenant system. And then as you can see, one of the things we also don't support is .NET CLR stored procs. But you have noticed, for those of you that have been paying attention, last service update, we enabled support for spatial data types. Spatial data types is an implementation using .NET CLR. So as you can see, we are starting to add all these things back in over time. One of the great things about a cloud service is that we're able to very quickly iterate on this. We don't have to worry about an 18-month or a 24-month ship cycle where you need to wait such a long time for new features. One of the big things we heard once we launched SQL Azure last year was things like spatial data. And when we listen and when you guys tell us you want a feature like spatial, we go ahead and we implement it. One of the other key pieces of feedback we got were, so you expect me to use a cloud database, but you don't give me any way to back it up, right? So what did we just do? Inside the last service update, we gave you the ability to make backups or copies of your database. So feedback is really, really important. It's really critical for you guys to tell us the kind of features that you need to make this a more viable solution for you. Or if there's areas that we can improve the experience for you, let us know that as well. So just to summarize really quickly as far as what works and what, your mileage may vary. From an API support, we have things like ADO.NET, security models SQL Auth, adding retry logic to your connection management. We talked a little bit about what the database level stuff is supported, what server level stuff is not supported, and different ways of dealing with collation. On the slide before, we have links to MSDN that are constantly changing. We revved the service 8 weeks. So just because something is not supported today, there's a good chance it will be supported over one of the next service updates. So I would, take a look at those feature lists right there and check back and pay attention to the SQL Azure team blog, because we make lots of announcements on there as far as what's supported, what's not supported. So what about, we talked a little bit about things you need to consider inside your database tier. Excuse me, your data access tier. What about actually getting your databases up there? When we first came out with the service, one of the things that we heard a lot about was, Yeah, I get the chains of connections thing, but how do I move my data? How do I move my database? Please, please, please make it easy for me. So that's one of the things we've been paying a lot of attention to. We've been working really hard on the ability to take workloads, move them from SQL Server, move them up to the cloud, and move them from other database platforms to the cloud as well. And one of the things that we just came out with I think it's about 3 or 4 weeks ago, was something called SQL Server Migration Assistant. So SQL Server Migration Assistant, which has been out for quite some time, but now has support for SQL Azure. So you're able to take your Oracle databases and MySQL and Access and those databases, and Microsoft now provides you with a wizard to go ahead and take that database schema and data and move it to the cloud. So the version, we support MySQL version 4.1, Access 97 and up, and all versions of SQL Server are supported. And I think that brings us to the first demo. So let's actually go ahead and look at what the SQL Server Migration Assistant experience is like to migrate stuff around. And I apologize, this table is quite low, so if you just see the top of my head, I'll try to pop up every so often. Let's switch to my screen. Oh. Let's try that again. Maybe not. That was kind of weird, right? Try plugging it in. You know what? Why don't we try another projector if we have one? I don't see another. Do we have another VGA cable up here? No? Maybe? Do we have a bent pin? We don't have a bent pin. That's number one.
That's number one. Just push it up.
All right, everybody, let's pray for number one.
I think it's your piece doing that.
So let's try one other thing and turn down the screen resolution. Let's put it into 1995 mode. There we go, that's better. All right. We're back in the 90s. So let's look at this. So what I have here on my desktop is a Microsoft Access application. And so for those of you in the room that are developers, that are not Access developers, you might be sitting there saying, all right, why are you showing me Access? Access is not a real database. But to be honest, if you look across companies and look across enterprises, there are tens of thousands of these things out there today. And there really are. No kidding. And I get a lot of phone calls from CTOs and CIOs that are really concerned because they have all this data spread out across their entire enterprise, and they don't have any way of having any visibility of it. So by taking these databases and moving them up to the cloud, it's a good way to go ahead and gain the visibility across the enterprise. So here's just a regular Access database, nothing too simple. It's just baseball statistics. I'm going to go ahead and close out of this and launch into the Migration Assistant. Here we go. So when I launch this, the first thing it does is it brings me into a wizard and guides me through the steps of migrating this database up to the cloud. And this you'll see if you've used the Oracle one or the MySQL one, it's very similar the way this progresses. So if I go ahead and click Next, I'm going to say right here I want to migrate to SQL Azure. I'm going to click Next again. I'm going to add an Access database, which is my baseball stats one. I'm going to go ahead and click Next. And just to make sure that there's no smoke and mirrors here, let me go ahead and connect up to one of my SQL Azure databases and just show you that there's nothing out there. This is not the man behind the curtain. There's nothing out here as of right now. So if I go ahead and click Next, and I type in my password, word 1, and I click Browse, do I want to continue? I'm going to say yes. I'm going to say create a new database. I'm going to call it baseball. As you see, I've run this demo before. Go ahead and click Create. So it's going to actually go ahead and create a new database up on SQL Azure for me. I'm going to click Next. And now what it's asking me to do is it's saying, do you want to go ahead and link your tables? So by clicking this checkbox and going next and letting this run, it's going to actually crack open that Access application, migrate the schema, migrate the data, and add all the tables that the Access application is using. It's going to add them as linked tables. So that way the Access application will be modified to now run. We'll still use the local Access runtime on the desktop, but all the data will now live up in the cloud. It's almost done converting. Let's give it a couple more seconds. So it's migrating all the data, migrating all the objects. It's continuing. And if we go back here and refresh, we should see that new database, which we do. It's still migrating. Let's open that up. So it's almost done. So now what I'm going to do is I'm going to type my password in one more time. And what it's actually going to do is it's actually going to store, and this is not, we're going to be warned, it's about to store my password in clear text in the database. You probably wouldn't want an SA level credential right here. You might want to have a user that has less privileges. And it's going ahead and linking all the things over. It's just about done. One more second. Just one more. See, this is the thing. If I was running this from my house with fiber, I would have been done 5 minutes ago and playing with my kids. So here, it's all done. So now if I close this and back out of this application, do I want to save it? No, because I've run this half a dozen times. And if I go ahead and crack open this Access database, I now can see that all the data from that database has been migrated over. It's now added all the different linked tables. So that way I have access right now running on my desktop using a cloud-based database. And so now I have other opportunities now that this data is up in the cloud. I can now begin to think about, hey, maybe I take this Access application, maybe I move it over to some sort of forms over data ASP.NET application. Maybe there's some other things I might want to do with this data. It's now highly redundant and fault tolerant. If Susie in accounting, if her machine goes down, I don't have to worry about all this data being lost. So that's this migration assistant for Access. Who's Joe in accounting? He's the star, He's the star. I actually have 4 children, no boys. So every time, it kind of tugs at my heartstrings that I don't have a little son in Little League. I have cheerleaders, though, And I got to tell you, I don't mean to sidetrack, and then we'll talk about this. Cheerleaders have it so much worse than the boys do, because the cheerleaders, they have to cheer all day long. The boys, they show up, they play their game, they go home. And me and Mom are sitting there, all right, it's been here for 14 hours. Let's go. So that was migrating Microsoft Access to SQL Azure. So what about some more complex scenarios? Access is a great tool. I love it, but there's, coming from the SQL Server team, there is more than just Access. So now let's start to talk a little bit about the different options for taking your SQL Server databases and moving them up to the cloud. So within Management Studio, as of CTP 3 of SQL Server Management Studio R2, which is now, it's been released for quite some time, we have support for something called Generate Script Wizard. And we'll go through that in a couple seconds. But what Generate Script Wizard enables you to do is go ahead, point to an on-premise database, right-click, go to Tasks, and say, go ahead and script out this entire database and give me something I can go ahead and run against my SQL Azure database. Or, to the contrary, maybe I want to take this SQL Azure database and maybe I want to move it on-prem, so you have the ability to go back and forth. And all the tools that we're going to discuss moving forward, that gives you do have the ability. It's not just on-prem to cloud. You can go from cloud to on-prem. It's not like, at Microsoft, we're like, we have you in the cloud now. We have your data, So you can go back and forth. But the Generate Script Wizard is a great thing for moving very small databases or databases with a lot of schema, but with a little amount of data. Because one of the problems is it does inserts for each row of data. And for those of you that have used SQL Server, the DBAs in the room, that's not really the best way to go ahead and do it. But there are scenarios that this is good. If you have a very small database, this is a great way to go ahead and migrate it. So if we just, this one's going to be really quick, not to bore you guys. Come on, monitor. There we go. Perfect. So going back to Management Studio, if I go ahead and connect to one of my other instances running locally, and once again, for those of you that have never seen SQL Azure, same experience using SQL Server Management Studio for going ahead and working with your databases. If I go ahead and open up and pick my AdventureWorks database, right-click, go into Tasks, and go into Generate Scripts. Once again, it's going to give me a wizard just like the wizard I had a little earlier ago. And this is a very easy to run wizard. It enables you to go ahead and choose what objects you want to script out. But the one thing that we don't make kind of clear to people, and we've hidden it underneath this advanced button, is how do you go ahead and actually go ahead and script something for SQL Azure. And it's right there. So if we just highlight that for a second. So one of the things we talked about a little earlier was that there are some differences between SQL Server and SQL Azure. If I try to issue a create database and I try to specify data file and log file properties in SQL Azure, it's going to fail. So what we've done is we've gone ahead and modified and added this additional option inside Generate Script Wizard, so that way when you say SQL Azure database, it'll know the type of T-SQL syntax to go ahead and spit out to make migrating your database able to be moved up to SQL Azure. And then once again, there's one more option that we hide, and that's what you want to actually go ahead and script, schema or schema in data. So once again, if it's a small database, in the tens of megs, this might be an okay option for you. But beyond that, we have some additional tools that we'll cover in a couple minutes that'll be a much more elegant way of moving your database. But just for a sense of completeness, if I go OK and click OK and go new query window, go next, it'll actually go ahead and generate me a script against my AdventureWorks database that I can go ahead and take and now run up against SQL Azure. So we'll let that run and go back to the slides for a moment. There we go. So another option, small databases, a little amount of data, Generate Script Wizard, great way to go. So what about DAX? What about all these things you've heard Microsoft talk about for the last year? Something called a DAC. A DAC stands for a Data Tier Application Package. And what this is meant to solve is kind of the disconnect between DBAs and developers. So if you think about it, a lot of times, I was formerly a dev before I moved over to the program manager, discipline. And one of the things that I would do either at Microsoft or at other companies I worked for is all the devs would work together in silos. We'd all sit there and write all this code. And at the end of the day, when sign-off happened and we were ready to go ahead and do this deployment, we would take this script and we'd throw it over the wall to the DBA and say, here, go install that, right? And the DBA would get this script and the DBA would be like, what is this? What kind of hardware do I need to run it on? What version of SQL Server? What are the different requirements that you have for this database? So what Data Tier Applications enable you to do is it gives you a self-contained way of moving schema throughout the development lifecycle, but also specify developer intent via policies inside that file. So that way, when you do throw that over the wall to the DBA can say, aha, I know now inside this manifest file that the requirements for this database. Another great thing about data tier applications is that who here has been in the process where they've gone ahead and they had version 1 of their database, and they start working on version 2, and then all of a sudden they have to write this massive upgrade script to go from version 1 to version 2 and moving all the data. It gets ugly. And the guy on the team that has to do that, he's always the disgruntled guy that hates everybody else. What DACs enable you to do is, if you have a project based upon a DAC, and you release version 2, the DAC has, the sense about it to be able to go ahead and automatically generate and automatically upgrade your database for you. So there's no worrying about, generating these update scripts and making sure everything goes as planned. It's supported inside Visual Studio 2010, also supported inside SQL Server Management Studio R2. And one thing you'll begin to see over time is the DAC, or the data tier application, becoming the new standard way within Microsoft of looking at database projects. For those of you that are familiar with database projects inside Visual Studio, when you go file new database project, you're presented with like a whole bunch of stuff, and you're like, oh, which one do I choose, you know? If you don't know what project, you know, it makes it kind of, you know, difficult. So we're looking to standardize all that to give you a nice, easy way and a new deployment mechanism for deploying these things. And those are DAC packs. So one of the things to keep in mind around DAC packs, and we'll actually show you one in a moment, is that DAC packs are great for schema. They're great for upgrading existing databases with data in them. What they're not designed for is going ahead and installing databases that have a lot of data in them. You can do it. There is something called a pre-install and a post-install script that you can actually go ahead and kind of hijack for implementing and inserting reference data and small amounts of data. But that's not what it was designed for. That's not to say in the future that we're not going to enhance this capability to go ahead and have more robust, you know, data import capabilities into it. But today, that's not what it was designed for. So if you're looking at anything beyond just like side tables and reference data, you probably don't want to go ahead and put that inside the DAC itself. You probably want to go ahead and do your DAC deploy and go ahead and move your data over separately. So if we actually look at the DAC, we have multiple ways of interacting with the DAC and interacting with my laptop as well. If we can, there we go. So getting back to the point earlier around DBAs and around throwing stuff over the wall to them, if I go ahead and close out of that, that's the script for AdventureWorks. If I expand this management tab, and notice that the only database I have out here right now is baseball. If I right-click on data to your application, I can click on deploy data to your application. So as me playing the role right now of DBA, I can actually go ahead and, once again, a very similar wizard, I can go ahead and browse for a DAC pack that my developer might have just given me. And here's one for the pubs database. I can go ahead and open that up, and I can see different pieces of metadata around that. I can go ahead and click Next. It's going to validate the DAC package. And then if I go ahead and click Next, it's actually going to go ahead and deploy this database, deploy to a new database up in SQL Azure for me, using the schema that was contained inside that single file. And if we notice, the one thing it can't script over is my Redmond login, which is Windows authentication, because we do not support Windows authentication inside SQL Azure. Additionally, as this is running, I can go ahead and I can go inside Visual Studio. And I can go New Project. I can go to Database. I can go to SQL Server. And I can go to SQL Server Data to your application. This is what I was telling you about before, about how, what am I going to choose here? So if I click OK, yeah, I'll open it anyway. It's creating a new project. So now within, and let's just close that because I don't want you guys seeing that. I can actually go ahead, now that I have a blank data to your application, I can go ahead and get started with, a couple different ways I can get started. Number one is I could just go ahead and I could just start designing my schema right in here. Or I have the option of either one, attaching to an existing script, importing that as a data to your application. I can attach to an existing database and extract all the stuff out of that and create a data to your application. Or I can actually go ahead and import a DAC pack and base my new project off of that. And so if I was to go ahead and attach up to a database that had already been deployed as a DAC, I can go ahead and import that, start to modify it, and then when I want to go ahead and do the upgrade, have the DAC system, otherwise known as DAC Effects, which is the programmatic API, automatically go ahead and enable me to do these upgrades for me automatically. So those are DACs. Another way of moving data schema around between SQL Server and SQL Azure. Let me just check on time. we're going to have to speed up a little bit. This is usually an hour and 15-minute presentation that I have to do in an hour, so I apologize. If for some reason we don't get through all this, or if I talk too fast, I'm available after this for as long as you guys want to hang out and chat, maybe grab lunch or something. We can continue the conversation. But what about transferring large amounts of data? Best practices always says use the right tool. So what is the right tool? Those of you that are familiar with SQL Server would know things like BCP and SSIS. In the performance talk later on today, I'm going to go into a lot around latency versus bandwidth. About if you have a lot of bandwidth but a highly latent connection, different things you could do from a batch size perspective for getting the most out of that connection and being able to really import lots of data over pretty much any connection up to the cloud. So if you need to transfer data, lots of data, use BCP and SSIS. We also have something called the bulk copy API, which is pretty much the same thing as BCP. One of the best practices we say are things like, disable the delay of creation of a non-clustered index and ordering the data. We have extensive guidance up on the team blog as far as, what are some of the best practices that you should follow for getting data into the system. One of the great things, though, is that if you're familiar with SQL Server, a lot of the same best practices and same tools and same things that we talk about for SQL Server just apply to SQL Azure. Under the covers, it's still the SQL Server engine. It's not something new we've created. We've just gone ahead and cloudified the engine to make it multi-tenanted, to make it scale out across hundreds of machines in a cluster. So BCP and bulk copy API to go ahead and start moving just the data. Then we have a tool called SSIS. I'm sure everybody's familiar with SSIS. It's Microsoft's ETL tool. And it's a great way to go ahead and get in there and get a nice design surface and start creating not just database import type functionality, but also transform. So if you want, let's say you have a database with a different schema, perhaps you want to break out tables into different tables and move them places. You have a very rich programmatic interface to be able to go ahead and perform these data transfers and data transformations. Once again, optimize the database for data import. A lot of the same things we talked about that were mentioned on the previous slide as far as non-clustered index and ordering data, it still applies. Batch size, we'll talk about that in the performance talk. Basically, one of the things to keep in mind when you think about latency and bandwidth is, let's say you had to move, you had to move 100 people from Auckland to Christchurch, right? And, the distance, is the latency. But the bandwidth is how many people you can actually go ahead and move at a single time. So if you have a high bandwidth connection, it's like having a really big bus. You could put all the 100 people on a bus at one time and move them in one trip. Versus you might only have a car where you have to make multiple trips. But the batch size enables you to go ahead and say, hey, I have a bus, but put 50 people on the bus, or put 100 people on the bus. So depending on what your connections are like, you can actually go ahead and tweak that to get the most out of your connection. And another great thing about SSIS is it enables you to do parallelization and basically upload data in multiple streams. We also have something called the Import-Export Wizard. Import-Export Wizard is available through SSMS. It's also available in the SSMS program group. And it's actually a wizard way of using SSIS. And it enables you to go ahead and actually move entire databases via a wizard, and it uses SSIS under the covers in the background. One of the great things about this is it allows you to save it. So whenever I go ahead and I walk up and I know I have to do some sort of SSIS project, I always start with the import and export wizard first. Because what it enables you to do is it gives you a good starting point, and then you can open up that package within SSIS and begin to modify and add some of the more intensive logic that you might want to do from within SSIS. So great performance out of the box. So we do have a discussion later on today around database performance in a multi-tenant environment. That's the talk I'm giving at 4:15. We touched upon this very briefly about latency and bandwidth. And it's something to keep in mind because you might have a really, really large connection to the internet, but the latency between here and the data center might be very far. In the performance talk, we'll actually show you how you can actually test latency to see what the round trip time is between my laptop here and perhaps one of the different Microsoft data centers. And so one of the things we like to advise you about is to test it. Because just because Southeast Asia might be geographically close, there might be a fiber connection between here and the States. So putting it in north central U.S. might actually provide you a better experience. So it's something to think about, something to keep in mind, something you should test for yourself, depending on the time of day that you have your workloads running, and also depending on where the majority of your clients are. You might have clients in the middle of the sticks. I was out to dinner with some friends from Australia last night, and they were telling me, "Oh, don't say out in the sticks, say the boon something." But I seem to have forgotten what the way of saying it in this part of the world is. But keep in mind that just because it's geographically close doesn't mean you might have the best connection to it. And just in summary, the database migration options. We talked about SSMA, which is great for moving when you're moving databases that are not on the SQL Server platform. We talked about Generate Script Wizard. It's great for moving schema. It's okay for moving small amounts of data. We talked about DAC packs for giving you a way to encapsulate entire schemas into a single file. We talked about SSIS, which is really a great tool for moving things around. It gives you a nice, pretty interface for doing these data transformations and moves. And then we talked about BCP for moving data and moving large data. We also talked about how you should tweak that batch size to make the most of your connection. And what's coming in the future? So we touched upon this a little while ago, and a lot of the feedback you guys provide to us, we act upon. Things like database copy that we just came out with last week. Things like people in the other parts of the world that want collation. People that come up to us and say, oh, for instance, even though we trust you, Microsoft, we won't open up port 1433 outgoing, so we can't use SSMS. So what do? We came out with a web-based tool for being able to manage your databases, something called Project Houston. So I think the key point I'm trying to make here is that your feedback is key. If there's something you like, if there's something you don't like, you really need to let us know. If there's a specific scenario you're trying to target with SQL Azure, please tell us. We're here to help. I wouldn't come out to all places of the world like Auckland and Australia and whatnot if it wasn't important for us to help you guys really onboard onto the platform. So I think that's it. I think we have next is Q&A. So we have 5 minutes for Q&A. So we can start doing Q&A in here, and if we run over, then we can go find someplace nice to have a quick chat. So I saw the guy in the back row first.
What's the database size limit?
So the question was, what is the database size limit? So today the database size limit is 50 gigabytes. We have said that we're thinking about moving beyond 50 gigabytes. There are reasons why we have a database size limit, and it has to do with the fact that we do maintain multiple copies of your database, and if something should happen to where your primary is located, we need to be able to spin up a second replica of your database very quickly. So it's something we're definitely thinking about increasing the greater than 50 gig. If you also look at the futures talk we gave at PDC last year, we also talked about some new work that we're doing to build some of the common data sharding patterns into the platform itself, so that you have the ability, when a database starts getting large, the ability to type in a command to split that database into two physical databases and have a layer that knows that that database was split and knows how to route things accordingly. So it's something that we're working on. We've said it's on the roadmap. So today 50 gig, but it's going to be increased. There was another one right there, sir.
Certificate authentication, and can you replicate an Azure database, and can you subscribe to an Azure database from a
So using certificates for authentication, the answer is not today. We are looking at other authentication and authorization models. I know certificates, is something that we've talked about, but I think you would probably see something more around some sort of token-based thing before you would see certificates. Managing certificates at scale is not a very easy thing to do. As far as being able to replicate and do subscription-based stuff, it's something we're thinking about, but probably not over the next year. I wouldn't see that. Customers that want to do that kind of replication, we're pointing them towards using the Sync framework. Sync framework version 2.1 just came out last week. It has a lot of optimizations built into it for doing synchronization and replication of data across multiple SQL Azure databases and multiple SQL Server to SQL Azure databases. So I would suggest you think about using that because it's a really great way to do that, provide that same level of functionality. Right there?
Any reporting services support yet?
We did announce that reporting services was on the roadmap. I can't commit to when, but it's really not that far off. Look for some major announcements towards the end of the year around that stuff. But yeah, any other questions? There's a question back here, sir.
What sort of backup and geographic topics do you expect?
So following the roadmap we announced last year, we said you were going to get three things. We said you were going to get database copy within the same geography. Then you were going to get something called continuous copy, which is basically to set up this online replication so that way you say copy continuous foo to bar, and it'll actually make sure that those two databases are in sync at all times. And then the third thing we said we were going to do is geo-replication. So database copy we just announced, it's available today. The other two is something what we're currently working on. I can't commit to a time frame, but it's something we're actively working on. There's a question back here. I'm sorry? The pricing model. So the pricing model is for a 1 gig database. It's $9.99 a month. That's for what we call the web SKU. Then we have something called the business SKU. That starts at $99.99 a month for a 10 gig database. And it goes up in steps from 10, 20, 30, 40, 50. The web edition database can also go up to 5 gigabytes. The one thing to keep in mind that we don't do a good job of telling customers is that you only pay for the databases you consume on a specific day. So if I walk up to a database and I do a create database, web edition, 1 gig, I'll be charged 33 cents per day for that database. So we have lots of customers that have these spiky workloads, which they'll have to go ahead and spin up 100 databases, to do some sort of stock transaction or something of that nature. They'll have those databases spin up. They'll live for a day because they need this massive capacity, and then they'll spin them down after a day, and they only end up paying 33 cents for each one of those. We also charge for bandwidth into and out of the service as well. All pricing information for the service can be found on windowsazure.com. And for those of you that do have MSDN subscriptions, there is an MSDN offer for you to get free access to the platform as well if you want to start playing around with it as well. Yes, sir.
Question. So if I'm based in Auckland, where's my data being hosted?
You got to choose. You get to choose between 6 different data center locations throughout the world. There's 2 in the U.S., 2 in Europe, 2 in Asia Pacific. We typically don't announce where the actual data center location is, but if you do a Google search, yeah, I said it, you could probably find out where the actual locations are. So, and I think we're about out of time because I'm being looked at from the back room. So thanks. If you guys want to learn more about performance, there's a session later. Otherwise, come grab me afterwards, and I'll be happy to answer other questions.